This module, which is our final module, we're going to talk about confidence intervals. And what a confidence interval is, I guess, is most easily compared to a point estimate. Sometimes when we wonder about the average or the mean of a population, we take a sample and find a sample mean, and that's called a point estimate, where we estimate what a data set looks like with one number. Sometimes it's more appropriate to use a range, and that's what a confidence interval is. So instead of when somebody asks us how many hours of TV we watch per week, we might say, oh, 6. A confidence interval would be, maybe 5 to 7. And we find ourselves doing this probably without thinking about it too much. What makes it a confidence interval is we can have different levels of confidence about how sure we are that this range we give contains the real mean. And there are certain confidence intervals that are more commonly used. And we're going to do a little calculating in this video for some z-values for these confidence intervals, because you end up using the same ones over and over again. So you just go ahead and figure them all out, write them down on your normal distribution chart, and then you can just refer to them. You don't have to keep making them up. Let's see, 80%, I think we might use that a little bit. 90% is pretty common. 95%, you see. 98%, and finally 99%. I used to wonder when I was in your chair taking this class, why, if we could be 99% sure, why would we ever want to be less? Well, sometimes in order to be 99% sure, if the data has a lot of variation in it, sometimes your interval has to be so big that it almost is meaningless. For example, if we said you wanted to know what your starting salary would be if you came to work at SVCC, and I said, well, I'm 99% sure your starting salary will be between $20,000 and $150,000. So if I give you an interval that big, that doesn't tell you anything. So sometimes you have to, when there's a lot of variation in the data, sometimes you have to accept a lower confidence level in order to have an interval that's worth anything. So what we're going to do in here is figure out how many, in order to be 80% confident, how many standard deviations do I need to go on either side of the mean? And the same thing for each one of these. And we'll write these down. We'll make a little table with our confidence intervals here and the z-scores here. And then you can just write that down and reuse it when you're doing the problems in this review. So, 80% confidence means we want to fall in the middle 80% of the distribution, which means since this is symmetric and we're taking 80% right out of the middle, that means the other 20% falls in these tails. 10% here, 10% here. We need to find this z-score. Unfortunately, because of the symmetry of this curve, when we find this z-score, this one's going to be negative because it's to the left of the mean. But this one will be the same over here, but just the positive of that number, because this is a mirror reflection. The symmetry of the curve makes it a little easier. So when we do this, we're going to find the negative z's for all these, but we're only going to record them as a positive number because the formula we use to do these intervals takes care of the negative positive thing for us. So we're just interested in the positive z, but we're going to find it on the negative side because it's a little easier. And we learned in a previous problem that if 10% of the data lays over here, we use our table backwards, we find 0.100, or what's closest to it. There it is right there. You can tell I've done this before on this sheet. We get negative 1.28. So that's a negative 1.28, which means this one over here would be positive 1.28. And that's the one we're going to record, the positive one, because the negative sign, you'll see later, that takes care of itself. 90% means I have 10% in either tail, or in both tails together, so I have 5% here and 5% here. That's 0.0500. So we find the closest one, and this one is actually split in between these two. So we're just going to pick one, negative 1.65. Some people might use 1.64, some people use 1.65, but it's only 1/100th of a point, so I don't think it really is going to make any difference. 1.65. So that means the positive one, 1.65, and the one we're going to use in our calculations, 1.65. 95%. That means we have 2.5% here, because we have 5% total left over, and we split that evenly between the tails. That's 0.002, excuse me, that's 0.0250. 0.025, right there, 1.96. That's negative 1.96, so we have 1.96. So that's telling us if we want to be 95% confidence that the true mean falls in the interval we use, we're going to allow ourselves to go on our interval 1.96 standard deviations on either side of the mean. That's all that means. So 98%, that gives me 1% here, 1% here, that's 0.0100. 0.010. Here's the closest one here, 0.0099, 2.33. That's is equal to negative 2.33 here, so it's positive 2.33 here, and that's the one we'll save, 2.33. One more. We got 1% divided into these two tails, so that means that there's a 0.5%, 0.5%, and 0.5% as a decimal is 0.0050. And you know, we're finding the negative ones of these because we have the area to the left, and that's what our table gives us. So that just makes it easier to do, because this table gives us, you know, area to the left. So that just makes it easier to find the z-score on the left-hand side. Just being lazy. 0.0050. Where are you? There we go. It's right between these two. We're just going to pick one. Negative 2.58. Negative 2.58. So this one's positive 2.58, which means if we want to be 99% sure, we're going to go 2.58 standard deviations on either side of the mean. And that's what I was talking about, making these having these intervals get really big. If your standard deviation is really high, when you take 2.5 of them on either side of the mean, that's how your interval can get really big, really fast. So it all depends on the variation in the data. But that's how we calculate these numbers, and we're going to reuse them over and over again. So I would write these down on your chart. Some charts you already have them on there. And then you can just keep reusing them, make life easy. And in the next video, we'll start working on some problems.